This activity consists of analyzing the Bansi building. First, we had to design the model in SketchUp. And in the Zephyrah plugin, classify the floor, the slab, the walls, and the glazed parts of the building. Later, we upload our model to Zephyrah Web. In the baseline concept, we place the project in the city of Guadalajara. In this part, we put all the criteria that the building currently has. The next part was to place ourselves on the envelope tab, select the Azure Climate Zone 1. After this, we go to the section of walls and we choose concrete. In the floor section, we choose tiles. At the next point, we have the infiltration section and we select crack infiltration. Finally, we place ourselves on the roof assembly and choose concrete. And in the middle column, we select non-residential. Here we can see the total energy and cooling that the building currently has. In this part, we create a clone of the baseline, which we call Clone A, in which only the facade glazing will be analyzed by means of the AOE, energy use intensity, and some data was changed so that the building had a better use of energy. In this first response curve, we have selected the AOE unit that analyzes the intensity of energy used per square meter per year. And it can be seen that if we have more glazed parts, the building takes up more energy to be able to cool it. In the next clone was analyzed the override glazing radio. We can see that in the graph we have the AOE and in the lower part the window to wall radio, in which it can be understood that if we increase the number of windows in the building, more energy will be needed to cool it. And even the right side shows the cooling graph with the percentage that will be used. In the next clone, the orientation of the building was analyzed in order to find the most optimal in energy meters. In the response curve, it can be observed that if the building were rotated between -15 and 10 degrees, the amount of energy that will be used for cooling will be less. The following clone was analyzed the shading software. In the response curve, we can see that the more horizontal shading there is in the building, the less energy will have to be used to cool it. So it is an aspect that must be taken into consideration to be implemented. Finally, the last clone in which the strategies that had the greatest impact on the building AOE were selected. In comparison with the baseline, we can see that the total energy of the building improved as well as its cooling. Therefore, the strategies that were retaken in this clone are optimal to improve the Torre Bansi AOE.